Good afternoon, I'm Bharat Ratajamohan, SIM student ID 102566384, QOL student ID 230656932. This is my project video for Object-Oriented Programming CM2005. I'll be showcasing my DJ application code along with its operation. I shall first begin with introducing my codes first. First, we have App State Management CPP and header file, which handles the loading, saving, and retrieving of file state between application bootups, meaning that when a user closes the application after loading their tracks and editing them, all the information will be saved and is retrieved when the user loads the application back up again. I'll showcase this later. Next, we have DeckGUI CPP and header files, which determines the user interface of the app, such as colors and position of objects such as buttons. DJ Audio Player CPP and header files is responsible for playing selected audio. Key Detector CPP and header files handles the energy-based key detection feature that I implemented, which satisfies a requirement for R3 of the project instructions. Playlist component CPP and header files initializes a playlist component with a table interface which can be seen below the text. Playlist row action CPP and header files are the code for the action buttons for each row of the table, such as add, queue, dequeue, and delete. I shall now run and build the project file to showcase the end product. This is the output of running the project. I have already loaded some tracks into the various stacks for the purpose of this showcasing. The play buttons when clicked to play the tracks already loaded into the decks, which can be seen from the waveform displays. I will showcase how I load the files later, but here is it in execution. I can also use the sliders to alter the speed and volumes of the tracks, which alters the resampling ratio and gain respectively. As seen earlier, clicking the stop button successfully stops the playback. I can also use the plus and minus buttons to add or remove text dynamically. Below we can see the playlist component with the tracks already added. It has aforementioned action buttons. Let's now add a file into a new deck. I will click the add button to open up file selector and click a random song, let's say Electro Smash. As you can see, it has been added. And we can also click the queue button to queue it into a vector to later be retrieved from. So clicking queue, we can see that the interface says that the button is queued. Or if we do change our mind, we can click dequeue to dequeue it as well, which can be seen. Or even deleting them is possible. So once again, we will add a random song called maybe Soft. Once I've queued it, I can click the load button, which will retrieve the track first in the queue and bring it into the deck, which can be seen here. I'll now showcase the key detection. DJs sometimes may struggle to pair songs harmonically, so they may click the match button to use energy-based key detection to find the songs that follow the similar musical notations with the reference song. We can see that clicking the match button has changed the row background colors of the tracks based on the compatibility. In the order of best compatibility least, we have dark green, light green, orange, yellow, and red. And we can see that this result changes for various songs that's used as a reference. I will now showcase that the app can save states between iteration, as mentioned earlier. I will now close the app and reopen it. So I have closed the app and I shall build it again. As you can see that after rebuilding, everything remains the same as was earlier, including the fourth deck with the new song that we've added in. So that will be all for my presentation. Thank you very much.